Next, let's work through a few of these gas evolution reactions. And so some of these may have some intermediates that might make it a little bit easier to do first. So let's go ahead and complete the double replacement reaction. So we're going to have sodium with nitrate. And then that's going to leave us with hydrogen and sulfite. So the sulfite, that's going to be the one that we're going to have to deal with. So this is going to be the one that decomposes. So this is going to stay the same, NaNO3. Plus, this is going to break down into water, which is going to be a liquid. And that leaves us with SO2, and that's going to be the gas. All right, so now we can balance kind of from here. All right. It's probably easiest to balance this part, actually. Where you know we're going to need two of these. So we need two sodiums. We need two nitrates. Now we have two hydrogens. We have two hydrogens. Two nitrates, two nitrates. And then here is our S, and there's our three oxygens. Again, these are a little bit weird, and if you choose to use another method to balance the equation, then that's okay. All right, how about this next one? Ammonium sulfate with calcium hydroxide. Why don't we just perform the double replacement first? So let's do ammonium, that's +1, is going to go with hydroxide. All right. And calcium is going to go with sulfate. Okay, this is the one that's going to break down. So let's just rewrite calcium sulfate. That's going to stay the same. That's insoluble too. You can put a solid if you want to. Doesn't really matter. And ammonium hydroxide is going to break down into, same thing, we're going to pull off a water. It's going to be liquid water, and that's going to leave us with two H's and an O with ammonia gas. All right, so let's balance this thing. Calcium, calcium. Let's see, we need two ammonia, so we would need two waters there, because we'd need two of these in our balanced equation there, and then that breaks down. Okay. I know that gets kind of confusing. Okay. Next, HBr and NiS. Okay, so let's do the replacement. H goes with sulfide, H2S. Oh, look, that's already a gas. That helps. That's our nasty rotten egg one. And that gives us Ni, so that has to be +2, Br2. Now let's balance it. There we go. NiBr2, that'd be aqueous probably. Next, perchloric acid and lithium carbonate. All right, let's switch these around. Okay, so hydrogen is going to go with carbonate. So that's going to be carbonic acid. That's going to be our problem there. And lithium is +1. Perchlorate is -1. That'll be aqueous. This is bicarbonate. You know it as carbonated water or seltzer or Perrier. Any one of those things, carbonated water. All right, so let's break this down. So let's rewrite lithium perchlorate. That'll be aqueous because lithiums are always soluble. And here we're going to pull off a water. You'll notice that's kind of a common theme here. And that leaves us with carbon dioxide gas bubbles. Water's always liquid. All right, so let's balance this. We need 2 lithiums. 2 hydrogens, 2 perchlorates. Very good.